Hello everyone. Welcome to the other session of Big Data Tutorial series. Well, this session is about Apache PIG. My name is Rajan Chhetri. I am the instructor for the Big Data program, and in this session, I'll be sharing my knowledge and experience about Apache PIG and its implementations. So first of all, let us start with the agenda. So this session covers an in-depth understanding of what Apache PIG is. Once we have understood the Apache PIG and its benefits, we'll be talking about its data type to understand it in more detail. Then to gain a more in-depth understanding of Apache PIG, we'll be talking about the PIG architecture. And finally, to gain deep insights of data, we'll be implementing Apache PIG and seeing the various data analytics approaches. So first of all, let us start with what is Apache PIG. So Apache PIG is a high-level programming language. It is useful for analyzing large datasets, similar to MapReduce. So a PIG is a result of development effort at Yahoo. Now Apache is acquired by Apache project and is being developed under that umbrella. So if we talk about the previous programming models such as MapReduce, MapReduce needs to be translated into a series of map and reduce stages. However, this is not a programming model which data analysts are familiar with. So in order to bridge this gap, an abstraction called PIG was built on top of Hadoop. So when a data analyst is using Apache PIG, he doesn't need to know about the internal anatomy of how a MapReduce program works. He doesn't need to take care of map phases or the reduce phases. So it is easy implementation of MapReduce programming framework or programming model, which is basically abstracted by Apache PIG. So as a summary or as a conclusion, Apache PIG enables people to focus more on analyzing bulk datasets and to spend less time on MapReduce understanding. Let us try to understand PIG more in detail. Now, basically, there are two components of Apache PIG. One is a high-level PIG Latin language. So PIG Latin is basically a language which consists of a set of commands that we use for analysis purpose or for manipulating the data. Secondly, there are two execution modes in which we can use Apache PIG. One is the local mode and second is the MapReduce mode. Now, what is the difference basically? The difference is that when you execute Apache PIG scripts or commands on a local mode, the data which is being manipulated is residing on the local system. So it is not a distributed architecture, it is a standalone single file system. We can leverage the efficiency of PIG scripts or PIG commands in a distributed architecture when we execute PIG in a MapReduce mode. When we execute PIG scripts or PIG commands in the MapReduce mode, it basically connects to the Hadoop cluster and read writes on HDFS. Now there are two ways through which a developer can interact with the data, and one is the interactive mode. So that's basically using a terminal for executing the commands similar to Hive or HBase. So we can use a console and type the commands, and that will be the interactive mode. Second is you can write the PIG scripts. PIG scripts similar to, you can say, Python scripts. You can write the scripts and you can execute the script which consists of set of commands all at once. So it is entirely the choice of a developer and the need of the situation of any specific implementation. Let us talk about these components more in detail. So let us talk about PIG Latin first. So what exactly is PIG Latin in detail? So a pig Latin is basically a program which consists of a series of operations, or you can say transformations, which are applied to the input data to produce some output. Now these operations describe a data flow which is translated into an executable representation by the pig execution environment. So when we execute commands on any input data, underneath, results of these transformations are a series of MapReduce jobs which a programmer is unaware of. So in a way, pig allows the programmer to focus on data rather than the nature of execution, which is the beauty or the simplicity of pig commands. Pig Latin is basically a relatively stiffened language. So it means that it uses the familiar keywords like SQL, for example, let's say join, group, or filter. Now I told you about the execution modes as well. So local and MapReduce are the two execution modes. In local mode, pig runs in a single JVM and makes use of local file system. This mode is suitable only for analysis of small datasets using pig. But in case if your data is exceeding the capacity of a single system, it is suggested that you stick to the MapReduce mode. In this mode, the queries written in pig Latin are translated into MapReduce jobs and are run on a Hadoop cluster. MapReduce mode with the fully distributed cluster is useful of running pig on large datasets. So, no matter which execution mode you are using, whether it is local or MapReduce, you can interact with the pig environment only through two modes. One is interactive and second is the batch mode. Interactive mode, as I mentioned earlier, it is basically the usage of a terminal where the developer can interact with the data using the pig commands or the pig Latin commands. If in case if the job automation is required or multiprocessing is required, so in order to speed it up the data processing, we can write a script for that. So that is called a batch mode. Let us understand why it is easy for a pig developer to perform the data analysis operations using pig compared to the similar data analysis programming models such as MapReduce. So the very first advantage of using pig is the similar familiar words like SQL, which are already there in the pig Latin commands. So pig Latin provides us certain commands for manipulating data such as joins, distance or counts or loading, so which are similar to the SQL frameworks, SQL programming language. So if any learner or a student or a candidate is already familiar with the SQL-like language, it becomes pretty easy for that particular learner to adopt the commands which are provided in the pig Latin. Apart from that, if there is a fresher, that he can also understand the pig Latin very easily because it is a very simplified wordings they have used in the pig Latin command. If the data analysis requires the data manipulation in multiple stages, so instead of manipulating the data using the pig Latin commands, what we can do is we can prepare a script of commands which will manipulate the data sequentially in different stages. So pig supports the batch execution via pig scripts. Apart from that, pig scripts are not you know uh, not complicated, and they are not like they are not complex similar to other programming languages. So if there is any error in pig script, so you will get that error you know uh, instantly while compiling the scripts or while executing the script. You'll get that error instantly, which will prevent the Java level errors. Now, yes, we can execute the pigletting commands using the interactive mode. As I told you earlier, that is basically the usage of the terminal, which is used for executing the pig commands. There are various advantages of pig, the reasons behind its popularity. So I'm going to explain some of the advantages of pig. So the very first advantage of pig, which makes it's the first choice among the data analyst professionals, is basically it removes the need for the users to tune Hadoop. So it doesn't requires, the programmer need to know about the Hadoop internals, its architecture, its working, or its anatomy. So in simple words, it basically insulates the users from changes in the Hadoop interface. On the other hand, PIG also improves developers' productivity. Uh, let's say the 10 lines of PIG Latin are equal to, let's say, 200 lines of Java codes. So what takes 4 hours to write in Java takes about 15 minutes in PIG Latin. So that is the efficiency of PIG Latin. So we can do more using less lines of code. Apart from that, it also opens the system, or you can say the domain of data analysis, to the non-Java programmers as well. Now, Pig is pretty popular because of its features, and its versatility. Now, Pig provides supports for the data type, that we'll be discussing. It provides, support for the user-defined functions that we'll be discussing. Apart from that, when you work with the data in Pig, the metadata is actually not required when loading the data. So as I told you earlier, it can operate on both the types of file system, whether it is local file system or STFS, and it has the similar design patterns as I mentioned earlier, such as joins, districts, and the counts. So the scenarios where we use Pig is a wide domain. Basically, it has a wide implementation where we can implement the Pig. For example, we can use Pig for weblog processing. We can use Pig for data processing for web search platform. We can use it for ad hoc queries across large data sets, and we can also use it for the rapid prototyping of the algorithms. Now, if I tell you about the popularity of Pig, Yahoo being the originator of Pig uses it mostly. Approximately 40% of all the jobs at Yahoo are, implemented via Pig. Twitter is also, the other well-known user of Apache PIG. Now, let us talk about, some of the terms which we use in PIG to, describe the data. So the very first term here is basically the atom. So what exactly is the atom basically? So atom is basically the scalar value or the individual value which we use to describe the data. For example, let's say 1, 2, 3, 4, 5, 6, 7, 8, and 9. So any individual value, right, is called an atom. The second, term that we use to describe the data in Apache Pig is a tuple. So what exactly is a tuple? A tuple is an ordered set of fields. It is used to describe data like a row. So for example, if I provide you an example of a tuple, the tuple would look like this. So I would say, let's say 12.5, uh, hello world, and let's say some -5. So this is how a tuple looks like. Then there is one more term that we use in a tuple. It is called a bag. So what exactly is a bag? So a bag is basically a set of tuples. So how a bag would look like? A bag would look like this. So I would say uh, 1, 2, and 3, and 4, 5, and 6. So this is how a bag is supposed to look like. So a bag can be described as a unordered collection of tuples. You can say it is a relation which is of special kind. So we do have concept of outer bag and inner bag in PIG. So that is also one of the concept that we use in Apache PIG. And finally, we have the other data structure in Apache PIG, and that is basically a map. So what exactly is a map? A map is a pair of a key value. So a key value pair is referred to as a map. So you must make sure that when we are using map, keys must be unique, and generally it is supposed to be a string or char array, whereas the value can be of any type. Let us discuss the various data types which are provided by the Apache PIG, and these data types are falling under the category called scalar types. So these scalar types are basically used to store the atoms or the atomic values in the Apache PIG. So we have these data types categorized under various categories such as integers, where we have int and long, decimals where we have float and double. We have binary data, which is byte array. We have char array, boolean, datetime, and for the bigger values we have the big integer or the big decimal. All these data types fall under the category called scalar types and are used to handle the atom values. Now, if I tell you about the complex data types here, these are used to hold the group of values. So a group can be represented in various forms, such as a tuple, which I explained earlier, which is an ordered set of fields, a bag, which is a collection of tuples, as well as the map. So, as I mentioned earlier, a map is basically a set of key value pairs where the key must be of type char array. Now, let us understand exactly, how Apache PIG works and what exactly goes on inside when we execute the pig Latin commands. So, PIG is basically a client application, and for implementing PIG or for using PIG, you don't really need a cluster. The reason for this, because there are two execution modes which are made available to us in the Apache PIG, and one is the local mode. So as I mentioned earlier, local mode doesn't require any cluster to be available, so that's why cluster is not a prerequisite for using Apache PIG. On top of that, if you want to analyze and manipulate the large data sets, and to take advantage of distributed computing, we can execute the PIG application on a cluster using the Hadoop-like framework. When we execute the pig Latin commands, these pig Latin commands are actually converted into the MapReduce jobs. But before they are converted to a MapReduce job, first of all, it goes through the various phases. So the first phase would be parsing the scripts, which basically checks for the syntax or the grammatical errors or syntactical errors. Then it performs the optimization. Optimization is basically like improving the efficiency of the application. So taking certain, you can say, making certain changes which can, improve the response time. And finally, it creates an execution plan. So execution plan can be called as a workflow, or you can say the stages of the execution through which the program is supposed to execute and produce the expected or the relevant output. Finally, once the pig Latin commands or the script is parsed, optimization is performed, and the execution plan is ready, then finally the application is submitted to the Hadoop cluster as a MapReduce job. So this is how exactly a MapReduce job looks like, and this is pretty complicated compared to Apache PIG. This is something, this is the code, you can say, which is generated once we write the pig Latin commands, and this code is generated for us by the pig engine or the pig execution engine. So we don't really need to know what Java internals are, what are the what is MapReduce framework, or what are the anatomy of MapReduce phases. We really don't need to know much about these concepts, and we can still perform the data processing and can get the expected results. Now, how it is working exactly, how it is working internally. So if you look at the big picture here, so it all starts from here. So uh, we execute the pig Latin scripts or the pig commands, or if there is any user-defined function, we can execute it on top of pig environment. Now, pig environment is having mainly two components. One is the compilation and optimization phase. So these compilation is for as I told earlier, it is for parsing the parsing the scripts, and optimization is for optimizing the execution. And once the pig scripts are compiled and optimized, they are submitted to the MapReduce engine along with the execution plan. And these commands or the scripts execute as a MapReduce job, and they work on top of you know uh, Hadoop. And for reading and writing the data, the SDFS layer is used, and then it produces the expected output. So basically, this part here is totally abstracted when we are using the Apache PIG. So in simple words, it basically opens, the door, opens the system for the non-Java programmers, and it is comparatively less complex, or its learning curve is less steep compared to the MapReduce framework. So let us understand exactly how to write the big Latin commands and how we can execute them on top of a cluster. And for that we'll be using the terminal, or the interactive mode. So let us start with the Apache Pig lab, and let us try to understand how to implement the Pig Latin to process the data and get the desired results. So let us start with the practicals, and for the practical purpose, here I'm using the Cloudera virtual machine. Now, Cloudera virtual machine is basically a standalone, you can say, Hadoop cluster, which is provided by Cloudera.com. I'm running this Cloudera virtual machine on VMware Workstation. So let us start by opening the terminal first of all. And before we work on Apache PIG commands, first of all, let us prepare the data. The data that we're going to work on is a driver underscore data.zip, and from here we'll be extracting this data. So let us extract. So this is the data which is available with us, and this data is about drivers. This is the timesheet, and this is the truck event text partition. All right. So you can have a preview of the data here. This is how the data looks like, and we can see that there are the columns here. These are this is the schema. So driver ID, name, SSN location. So initially I don't require this header to be there. So let us remove the header. So I'm using the VI editor for that, for removing the header. Now the data has been saved. Now let us remove the header from timesheet. This is the header. Let us first of all go through the schema. The very first one is the driver ID, week, hours logged, and miles logged. And finally, we have truck event text partition. It has also got driver ID, truck ID, event time, event type, long, longitude, latitude, event key, correlation ID, driver name, route ID, route name, and event state. So during the practicals, these headers are not required. So that's why these headers are being removed from here. And now finally we have prepared the data for both the files. Now the next step is to migrate this data from local system into the cluster. And for that, we'll use the command here, sdfs dfs-put driver_data and root. Now this command will be migrating the data from local system into the cluster. Let us verify the commands here. So here, using this command, we'll verify the data, whether it is present on the SDFS cluster or not. So it is there. Now we will enter into the PIG environment by writing the command PIG. It will take us to the prompt, which is called grunt. So you can see here, we have entered the grunt prompt, which is the PIG prompt. Now we will do the practicals sequentially here. The very first practical is to define a relation. Lab 1, define a relation. So you can think of a relation like a table. Let's do that. Truck_events equals to load / driver_data / truck_event_text_partition .csv using PIG storage, comma. So here we're using the load command to load the data from a HDFS cluster. This is the path of the data in HDFS. Now here we are using the PIG storage function to specify the delimiter which is used in the data. So because this is a CSV file, the delimiter here is comma. Let us specify the schema as well. Driver ID, which is supposed to be of integer type. Truck ID, integer. Event time, char array. Event type, that's supposed to be char array. Longitude, which is supposed to be of type double. Latitude, which is supposed to be of type double once again. Event key, which is supposed to be of char array. Similarly, correlation ID, driver name, route ID, route name, event date. Let us execute the command, and here we can see that we are able to create a relation here in Apache PIG. Now let us revise the various commands that we used while creating the relation. The very first one is the load, which is used to specify the file path. Now this file path is there of SDFS. PIG storage is a function which is used to specify the delimiter as, and then this is the schema. Let us check the schema by using the command describe. So here we use describe command to check the schema of any given relation. So you can see here the schema of the truck events. Let us try to print the relation. For printing the relation, we'll use the command called dump. As you can see here, when we executed the dump command, it started the MapReduce engine. And now it is running the MapReduce job internally. So here you can see that it is a pretty amazing abstraction of reducing the programming complexity compared to the other programming languages. We can easily work on Apache PIG using the simplified programming or command-based model, I would say here. So we have to wait for some time to get the desired results as it is running the MapReduce job internally. So finally, you can see here the data is being displayed. So data is available to us and it has been properly retrieved. Let us learn how to create a subset from an existing relation. Define a new relation from an existing relation. For that, we will write, let's say, truck underscore events underscore subset. So this is my new relation, and here I am retrieving the top 100 records from truck events. So limit is for restricting the number of records from a given relation. So from truck underscore events, we are retrieving only the top 100 records and we are passing it to truck events subset. Once we create any relation from any other relation, from existing relation, the schema is shared by the subset or by the new relation. So let us check the schema by using the describe command. Truck underscore events underscore subset. So you can see here, this shares the same schema as of the previous relation. Lab 3, select specific columns from a relation. So let us learn how to select a specific column from a relation. So we will fetch the columns from truck events subset. So let us create a new relation here, specific underscore columns. For each truck underscore events underscore subset, generate driver ID, event time, event type. So we have these three columns here which we want to filter. So here we can see some new commands here from Apache PIG Latin. One is for each. What does for each means? For each means from each record. So for each followed by the name of the relation, which is truck underscore events underscore subset. Generate is a command which is used to specify the specific columns, or it is used to specify the required columns. So there are three columns that we are filtering from the complete data or the relation, and these columns are driver ID, event time, and event type. So before we dump the data, first of all, let us check the schema by using the describe command. So here you can see that this new relation called specific columns is containing only three columns here: driver ID, event time, and event type. Let us try to dump the data and let us verify if it is providing us the same data. So we'll just wait for a few moments here as it is running the MapReduce job internally. So finally, we can see the output here, and as expected, we are getting or retrieving only the three columns. Lab 4, store relation data into a SDFS file. So in this lab 4, we'll be learning how we can store the data into a SDFS file. So for that, store specific underscore columns into pig output slash specific columns using pig storage, comma. So you can see here, I'm using a few new commands here for storing the data, and it is store. Store is for storing the data, followed by the name of the relation, which is specific columns, into the path here where you want to save the data. And this is the delimiter which will be used while saving the data. So once again, it is running the MapReduce job. We'll wait for some time till it saves the data into the SDFS. So it looks like the data has been saved. In order to verify the data, we will open the new terminal and we'll check for the specific path in SDFS. For that, we'll write SDFS dfs-ls root. So we specified the path as pig output. We can see it here. So we'll do the ls on the same directory. We can see the specific columns directory here. We'll do the ls on this directory as well. And finally, we can see the file here, part-r-5 times 0. We'll do the cat on the same file. So we can see here we have received the data which we computed using PIG, and now it is available with us in STFS. Lab 5, perform a join between two relations. So in this lab, we will learn how we can perform a join between two relations. We already have truck underscore events. We'll create a new relation here for the drivers. So let us create a new relation, drivers, load slash drivers underscore data slash drivers dot csv using pig storage, comma, which is the delimiter in the file or in the data, as driver id, int, name, char array, ssn, char array, location, char array. Yeah, that's right. And certified, char array, and wage underscore plan, char array. So here we created a new relation called drivers, and we have specified the schema as well. Let us perform the join. In order to perform the join, we first of all make sure that we have a common column here. So the common column between the two tables, or the common attribute between the two relations, is driver ID. Let us perform the join on the basis of this common attribute. Join underscore data, which is a new relation here. For joining the two relations, we are using a command called join truck underscore events by driver ID and drivers by driver ID. So here we have joined both the relations using the join command. We are using the by command to specify the common column between the two relations, which is driver ID. So first of all, let us describe the join data. So we can see here that it has fetched the schema from both the relations. Let's dump it. Join underscore data. So now it is running the MapReduce job. As you can see here, it was pretty easy to apply the join without involving in the programming complexity, which is again the beauty of the PIG scripting. So here we can see the data which is being fetched from both the relations. It is from both truck events as well as drivers. Let's do the other lab. Sort the data using order by. Let us learn how to sort the data in PIG. So in order to sort the data, we'll create a new relation here called ordered underscore data. Order drivers by name ascending. So here you can see that we have done the sorting using the order command on the relation called drivers, and the sorting is applied on the column name, and the order is ascending. And this will be creating a new relation which will be stored in ordered underscore data. Let us try to dump ordered underscore data, and let's verify whether we see the name in ascending order. So it'll take a few minutes here, few moments I would say, to produce the results. Join is a pretty complex process when implemented via MapReduce framework. But here, whether it is join or sorting, it is comparatively many times, I would say, easier in Apache PIG, which again makes it the first choice among the many data analysts around the globe. It is an abstraction of the programming which is provided by the Apache PIG. So here, if you look at this data, you can see the name of the drivers here. It starts with A, C, D, E, F, G, J, and so on. So here we can see that the data is in sorted order by the name in the drivers relation. Lab 7, filter the data. So here, in this lab, we will learn how we can fetch the specific records. For fetching the specific record, let us write the PIG commands here. Filtered underscore events equals to filter truck underscore events by not event type matches normal. Now here, for retrieving specific records, we are using the filter command. And the relation on which we are applying this filter is struct events. Here we are saying that the column event type should not have the value called normal. So wherever the event type column's value not matches with the normal, return only those records. So in simple words, we are filtering all the records where event type is not normal. Let us dump and check. So looks like there is an error. So let us learn how to resolve the errors as well. If we check the log here, looks like that was some internal error. So when I executed the code once again, it ran without any modification. So we are expecting the results anytime. So as per the filter, we must see the data where the value of the event type column should not be normal. So here we have received the data, and in console it is pretty difficult to observe. We must actually export it. But here, if I show you this data here, you can see the unsafe tail distance, unsafe following distance, and all these values where there is no normal value available. So that were the labs which we conducted in the PIG Latin. I hope you have understood all the labs. So with that, let us conclude the session. So finally, I want to thank you all of you for watching me for so long and for providing me with your attention. So if you have liked the video, please make sure you subscribe to the channel, like the video, and hit the bell icon. So thank you very much. Have a great day.